Hello, once more welcome to the desk for this, the 8th episode in this series on electronic bits for model railways. When working with microcontrollers, it's often useful to know what the blasted thing's doing at any given time. We've previously seen how to use a serial port to talk to a computer, how to turn on and off LEDs so we can have blinking lights. The blinking lights bit is quite useful, but doesn't really tell you a lot. We can talk to the computer, but what about when you're not connected to the computer? Let's have a look at adding a small display screen and how we can use that instead. So to start with, there's probably as many types of screens as there are controllers. From these simple liquid crystal displays really only able to show individual characters, through to sort of full colour touch screens able to show animated graphics. Some, as all of these here, are dumb devices where you have to tell them exactly what you want to do. There are some more advanced ones that have their own little controllers built in that you can say, draw a rectangle, and instead of the microcontroller having to work that out and work out what to do, the screen will do it on its own. So, yeah. For the purpose of this episode, we're only going to consider 3 general types of screen, and then we'll have a look in a little bit more detail. The first is this. This is a thin film transistor display, TFT for short. Move the rest of these out of the way. These come in many sizes and styles. This is a 320 that way by 240 pixel display, and hello, yeah, my microphone, reflective screen on it. This one's got a touchscreen overlay. Some do, some don't. These come in many sizes, 2.4, 2.8, 3.2, and I think I've seen some slightly larger ones. And these work a little bit like a flat screen TV. A lot of times you'll see an LED TV. What they mean is an LED backlight. And this has a light that shines through the screen. The screen itself will then tint itself with various pixel colours. Lo and behold, you get a colour screen. One thing these displays have in common, they take a fair bit of processing power to use them. As you can see, there's quite a few pins that connect it. This particular one's got an SD card reader on the back with some pins for that as well. These are quite useful. This little thing here, you can sit this on top of a microcontroller. Because it's got a screen and a touch screen and an SD card, yeah, it can be pretty good. This one uses a serial interface, serial peripheral interface called SPI. We'll have a look at that in a moment to move significant quantities of data. Most microcontrollers can control these. Less powerful ones will struggle to do the more advanced things with it. Basically because you keep having to regenerate the display. So if you do one of these with an Arduino Nano or a normal Arduino, you're going to struggle. But if all you want to do is display text, yeah, it's not too bad. Just one of the little tricks you can do with it. Just displaying text, you can tell it, write out text. You can get quite a bit of text on this. They're not brilliantly clear to read. They're not bad, but because it's got a backlight shining through something, you have issues with viewing angles. These are pretty good if you've got something like an ESP32 or the ESP8622 or something similar to that, where again, like I say, you can use it as a touchscreen as the complete display. I've used a number of these in the past. They are actually quite nice. They're quite useful. They're not that expensive. 7, 8, 9 quid, something like that for one of those. There's a type of them called a cheap yellow display. These cost a bit more. They've actually got a built-in ESP32 on the back. So you sort of flip it over and there's a controller on the back of it and there's all sorts of stuff. It's basically a computer. You add a thing to it and away you go. And we go on to OLED. Now these are the fancy new kids on the block. I've got a couple of these in different sizes here. This is Organic Light Emitting Diode. Now this is what the ones that advertise themselves cheaply as LED TVs are trying to pretend they are. These are really good. There's no backlight. This is the primary way of telling them apart. If you look on the pins and you see it's got something like BL or something like that, it's not an OLED display. These are a lot brighter. They're a lot sharper. These are what I use on Leopard Street. I've got some in this sort of size, these tiny little ones, although with a different interface. They are very clear, and even for such a small screen, they're very easy to read. You can get 8 lines of text on that and read it really, really easily. These ones are monochrome. I forget what colour they are, but they basically the LED lights up in a single colour. You can get them in yellow, blue, white. I think I've seen a couple of green ones. And they're not too bad. These two are 2 different sizes. I think it's 0.96 and 1.3 inch. 128 pixels by 64. They're pretty good. The interface, these ones have the serial peripheral interface as well. The ones I use downstairs have got a different one called I2C, which we'll have a look at in a minute, which is what this has got, which has only got 4 pins, which is useful. This one, let's move them out of the way. This one's slightly different. This is 128 by 128, and this one is full colour. Costs a little bit more, but it's a beautiful screen. I actually bought this to use on, that's why it's got a bent pin interface on the back. I actually built this to build a Scalextric's Starlight gantry, which never really went anywhere, so it could sort of display the rows of red lights and other bits, and then display other bits. So yeah, if you're buying these, have a look at the pinout. If it's got something labelled light, backlight, or LED, yeah, it's one of these. It's a thin film transistor display pretending to be an OLED. Depends what you want and what you're prepared to pay for. But these things are lovely. The colour ones cost quite a bit more. And to be honest, unless you need colour, don't bother. This is 128 by 32, so you can get about 4 lines of text on there. They're very good as like little bar graph displays. I mean, if you've seen the video on the main channel where I show the little test controller I've got, I think it's the video with the K3. I do a little DC power test before I put the chip in the thing. You'll have seen one of these in white as a little bar graph display for the speed controller. They're cheap, they're useful. Then we have liquid crystal displays. Now these are easily the most basic. They're best suited for lower power microcontrollers, although something more powerful can drive them quite easily. These are the sort of things we're going to look at shortly in more detail. So I've got these two here. This is a liquid crystal display. You may remember these from digital watches before they were mini computers and incredibly powerful. They're noted for being quite low power. Again, these two have an LED backlight. Most of them do. These ones you can see without turning the backlight on. You can also get ones that are blue with white characters, and there's some other colours. The main feature here is the liquid crystal display itself is see-through, and it can be energized to fill in little squares in black in this case. These have a character interface, so these have a grid of 8 by 5 pixels. This smaller one is 16 characters along and 2 rows. The bigger one here is 20 characters along and 4 rows. So funnily enough, that's known as a 1602 and that is a 2004. They use the same controller and the same interface. Now you notice on this one there's a lot of pins. It's not connected to anything. This has a parallel interface. 8 of those pins are data bits, and you can connect either all 8 of them or just use 4 of them. The rest are power, there's a backlight pin, and there's some control pins. You can drive one of these using just 8 pins, which is quite interesting. You can drive them quickly using the parallel interface. Thing is, liquid crystal displays don't have a particularly good screen refresh rate. So yes, you can dump data to them fast, and there's a lot of tutorials online about driving these with Arduinos that use the 8-pin interface. And yeah, they work. They're clear, they're easy to read, they're low power, they're text only, or a very limited level of graphics. You can sort of do bar graphs with them. This one, as you can see, has got something soldered to it. I'll turn this over. It's got this on the back. Now this is they're known as backpacks. What it is, this is a PCF 8574, which is what that is. And this uses the I2C interface, which is the same as that. So 4 pins. This is a serial interface. This will take some data in it will convert it and drive the output, which is quite useful. What that means is instead of having to have lots of wires, we can just control this with 4 wires. So yeah, this one's a nice little backlight one. We'll have a look at these in a little bit more detail in a couple of minutes. On the interfaces, there is actually a few types of this here. So you can have the basic serial port interface. This is literally what we have been doing with the microcontroller talking to the PC. And instead of, say, sending to one of these, if it had this sort of interface, when you say, I want to draw a square, to one of these you have to send it. That means this pixel must be blue, this pixel must be blue, this pixel must be blue. You literally send it, draw a square, and 2 points, and it'll draw a square. That sort of thing has a controller built in. They can be quite useful. Some of them have some quite nice interface libraries built in for drawing buttons and things like that. I've sort of used those before in industrial control settings. Yeah, they tend to be the most expensive, but in some ways they're the most useful because you can actually get them to do quite a lot, and they'll talk back and they can be quite easy to use. Basically, using one of those, you're offloading all of the hassle of driving the screen to the screen itself. So as long as you can work with the library it's got quite well. I've seen you have parallel interfaces, and it's called parallel because you're sending multiple bits of data in parallel at the same time. 4, 8 and 16 are the usual ones. There are some 18-bit displays, some of the colour screens. This is actually an 18-bit colour screen. It's just been wired up to use the serial peripheral interface instead of the parallel one. So as I say here, you would have, say, 4 data wires. You will put 0 and 1 on those 4 wires. You will send a clock pulse, and it'll do something with that data. A serial interface, you have to send them bits one at a time. So yeah. So parallel interface tends to be fast, needs more pins. That's basically that there. You then have serial interfaces in another way. You can have the serial peripheral interface. This is SPI on here. Here you have 2 data lines. One is called MISO, which is master in, slave out. Yes, not particularly politically correct terminology, but that's the way this thing is written. The other one is master out, slave in, so MOSI. In addition to that, there is a clock line, which is controlled by the master, and it dictates the speed. These can be fast. 10 megahertz, 20 megahertz, 40 megahertz, 80 megahertz. It's a good choice for colour screen. You've got a lot of data to shift, and away it goes. There's also a select line, and in the case of these, there's some other lines. Very commonly, you'll have a data command line, which tells the device what it's about to see is data, as in what it needs to show, or a command, in which case something it needs to respond to in a different way. Uses a fair few wires. It is fast. There's other things you can connect to that as well. There are port expander chips. We can have things like the 74595, which can connect to the same bus and can control LEDs. We'll have a look at that in an episode in the not too distant future. Then we've got, as we said here, you have the inter-integrated circuit, which is I to C. Now this is designed, I think Philips designed it. They came up with the protocol. This is designed so that when you have a thing, say you've got a TV. So you've obviously got the TV's got its main controller, it's got its tuner and that, and then it'll have a row of buttons somewhere probably, some sort of input. You might have an inter-integrated circuit bus talking between those buttons and the main controller. There may be another thing on that bus talking to the infrared. It's quite useful in this case because you only have 2 lines. There's a data line and a clock line, and the other 2 are power. You just broadcast information out on this bus with an address. I forget what address number this is. This is the one we're going to use in a minute. We'll find out what address it's on. This device can then respond to that and send back. It's not as fast. This is in the kilohertz speed range. 100 kilohertz, 200 kilohertz. Bit less computationally intensive. It's 2 pins. Because the speed is slower, the electrical interference characteristics are a bit different. It's designed to talk to simple things that don't need vast amounts of data sending to them. You can get sensors, keypads, light output things. There's all sorts of stuff you can do with this. There are obviously some other connections. For example, the analog VGA cable. Some monitors use HDMI, DisplayPort. More modern, much more powerful displays. That's a little bit out of the range of what you're going to connect to a microcontroller. Things like Raspberry Pis, they use those. And of course, there are other types of display we're not going to go into here. LED dot matrix, 7 and 16 segment LED displays, e-ink, e-paper, that sort of thing. Future episodes, might look at some of those and go back to the TFT and the OLED displays. I was going to use the little version of this that is built into the ESP32, but it's built in. It's not brilliant. It's sort of, it becomes, look, you just switch this on and this happens. So there we go. So moving on. So as you can see, there are several of these. So how the hell do you work out which one to use? And if you're in my case, where did that standoff pin go? Some of the screws are loose. It'll be around somewhere. Comes down to what you're trying to do. Now in this episode, we're displaying some simple status information. I'm going to use this display because it's got the backpack soldered onto it already, and it doesn't require much processing. We're also going to be in a little bit of a break with tradition using an Arduino Nano. There is a reason for this. I have a little project coming up for this thing, and this display is going to be part of it, so I'm going to make that into this episode. Now on Leopard Street, as I said, I used these things, this side, the little 128x64 OLEDs on my board controllers. You may have seen those. I'm using them to show 8 lines of text, basically because these things light up, because they are actually LEDs. Under a baseboard, they're very simple to read. They're also very clear, and that's why I chose them. I'm working on a train controller that uses one of these for its interface. It's not as clear to read, but I'll be holding the thing or I'll be looking directly at it, and I want the touch screen. I want the increased screen area so I can drive multiple trains. If Chris, if you're watching, this is going to be my version of the knob box. Yeah, anyway. So the type of connection is something you also want to consider. So I2C screens, like I say, very easy to connect. SPI screens much faster. Another consideration is availability. Now, as you can see, I've got a few of these things. Now, I'm going to use this. It's quite suitable to use with an Arduino Nano, but I could use this. I've got it. For what I'm going to use it for here, it'll be complete overkill. In fact, that would probably be perfectly adequate. But this is a bit bigger. It shows up on camera a bit easier. So yeah, you may be at the situation of, well, I've got these. I got a pack of them. Maybe you got one of the Arduino starter kits, and they come with these things. So I'll use one if it'll work. If the information you want can fit on a character display, and you've got one, use that. If you're looking to buy the things, to be honest, I would buy the I2C versions of these. They're fairly cheap, and you can get them in like 10 packs, and yeah. So what we're going to do is connect one of these up. So we'll have a look at this in the next part about how we do that. So back in a minute. Okay, so the first thing we're going to look at is this. Slight aside, I've literally just had to write a sodding program to show a picture file, because I want a picture file viewer that doesn't have a massive amount of screen taken up at the top by a menu and then a whole load of stuff at the bottom that says, oh, you can use our AI to do whatever. I just want to show the damn thing. Anyway, rant aside, this is the circuit diagram for this little board on the back here. So what we've got, and I don't know why it moves when I do that. So here's the chip, 8574. This little bit here is the important bit. We have the two data lines. SDA is data, SCL is clock. And what I'm looking for is this. This thing has got two pull-up resistors. SDA and SCL need pull-up resistors. Slight aside, you don't want too many pull-up resistors either. So if you plug a load of displays in, you may find it stops working. It's not too bad. And try it before you start trying to desolder anything. But anyway, that's what we've got. We have also got these little pads down here. Now these are these things over here. This has some more pull-up resistors. This sets the address this thing will respond to. We're not going to change that, and if you've only got one of them, you don't need to. This little jumper here is, do you want to use a different power supply for the backlight? Which we don't, so we just put that connector on there. And then here is the connector, and as you see, we're using four. So I'll bring the pointer over here so you can see it. We're using 4 data bits. This is the power jumper, like I say, LED anode connects to that, or you can connect another power supply. If you're driving one of these things on 3.3 volts, you might want to connect a 5 volt power supply. You might just want to use a different power supply. The transistor, again with a little bit of a pull-up, you end up with an optional line here, BT, if you don't, which comes out of the chip. If you don't set it, the backlight will be on. So you've always got that. This bit sets contrast. We'll have a look at that later. And then there's a little power light, which is on the back here, and that'll light up when we've got power. And the capacitor's just a chip smoothing capacitor. So how are we actually going to hook this thing up? Yeah, well, let's have a little look. Okay, so we're going to wire this up, hopefully quite simply. So the first thing I need to do is bring this down here so we can see this. I'm just using these simple connectors here. I'm going to put one onto there as it's going to be ground. That comes over here to a connector marked ground. And I'm going directly on this. I'm not planning on connecting anything else just yet. I will be later. VCC, which is supply. Just make sure I can get that on there properly. So that goes to the 5 volt pin. And we need to connect these two. Now, if you're using an ESP32, you can connect these to different pins. On the Arduino here, I've got the SDA pin, which is this one. This goes to A5, which is, memory serves, let's have a little look so I can see what I'm doing, that one. And then I've got SCL, which goes to A4. Now, on an Arduino, those are your I to C pins. So that's connected. If you connect to something else, it won't work. Other microcontrollers have their own pins. ESP32 uses pin 21 for SDA and 22 for SCL, and it allows those pins to be changed. The Arduino doesn't, so we're not going to. That's it initially. So what we're now going to do is I'm just going to power this up. So I need a suitable USB lead. And you'll have to forgive me on this one. I have all sorts of problems with these USB leads. So if I plug that into there. Now as you can see, the little red light has come on here. And this is going to be dragged all over the place by the wire. And if I try and do anything with that, it will lose its connection. The little red light on here has come on. As you can see, the board is glowing because the display has switched on. And if I can get this the right way round, and then turn that light off, which might help. Turn that light back on. I hadn't thought of this. This camera is going to struggle. That display is now working, and I can see a bunch of black squares on it, and you can't. So I may have to change this. I may have to change the software in this to turn the backlight off. Yeah. So what we're going to do to start with, I'm going to have a little look at some software, and then we're going to come back to this, and we're going to see if we can make this thing work. So, as before, we're going to use a library, and the library we're going to use is called LCD I2C. Now, I've already installed this. It's not installed by default. There's a liquid crystal library, which the Arduino software comes with, but this you can just install. This is designed to control one of these over this I2C interface. So I've installed that. Very good. There are some examples in there which we'll have a look at potentially. So what I need to do is tell it again to install that library. And as before, that's all we need to do with that. we then need to create our little interface, which is done like this, I believe. We call it LCD OX2724. Right. What's that doing? That's saying I want to create an LCD object. Remember how we did this for the serial ports? This is doing it basically the same thing for the liquid crystal display. We're going to call it LCD. This OX27, this is in hexadecimal, which is base 16 notification. Don't worry too much about what that means here. But what that means is every character, instead of being 0 to 9, also gets A, B, C, D, E, F added, because it can be between 0 and 15. Then we have the number of columns and the number of rows. Yeah, well, that seems reasonable. And what I'm then going to do, I'm going to do something just fairly quickly on this one, because I want to see if this actually works properly. LCD.begin. That tells the library to switch itself on. There is then a command I'm going to use, which I wasn't going to introduce until a little bit later, but I think I might need it. LCD.no backlight. And that should turn the backlight off. And what I'm going to do is just try and run that. Now, up here, I have set this thing to be on Arduino Nano. So it's on that COM port. And we go into here, boards. Board manager here is Arduino Nano. If you've got an Arduino Uno, it's one of those. That uses the same A4 and A5 pins. I've got one somewhere, but I didn't have the connector for it. COM4 is where it is connected. If you're using a Linux system, that'll say something different. And because I'm using a clone, there's this bit. By default, you'll get this top one, at Mega 328p. If you're using a clone and it doesn't work, try this one, where it says Old Bootloader. And if you're using something with an Atmega 16.8, use one of those. So let me just see if this runs. With a bit of luck, it should do. And it should turn the backlight off. And with a bit of luck, it might work. Uploading, is this uploading? I have a feeling this is going to come up with an error message. Oh, for God's sake. Right, so what I'm going to do next is tell that to cancel, time out. I'm then going to go into here and I'm going to change that to that one. And I'm going to try that. And we'll see if it works. There we are. That's worked. And very noticeably, it hasn't turned the backlight off. Okay, so yeah, I'm just going to change something else onto here as well, and we're going to see if it works. I'm going to go .print, and this should work. And obviously, this being YouTube, something like that is required. So let me just try that again. I'm going to see if I can get this thing to work. There's something else that may need to be done on this. Right. It would be very useful if I could persuade it to turn the backlight off. So I'm not quite sure why it hasn't. Right, I'm just going to try... Just the alternative one is just trying that, which should do the other bit. Yes, it's a lowercase one. Yeah, the thing with the C language, case matters. Yeah, for some reason this one is not letting me control the backlight, which is slightly annoying. If you can control the backlight, what you find is it works quite nicely. And we will go. Now it is also actually possible there's something else wrong here, but I'm going to try and find out. There is a little variable resistor on the back here, which is this blue thing, and you tweak that to adjust the contrast display. Or in this case, you tweak that and the display goes blank completely. So right. I suspect I know exactly what the problem is here, so I will be back in a second. Right, yes, problem existed between keyboard and chair, as it so often does here. I had the SDA and the SCL where I was the wrong way around. So, this is something else. This is a useful little program, so I'm going to show you this one. Go into here, go into examples, and you want wire, which is basically what the I2C library is called. And this is obviously off the bottom of the screen, which doesn't help. Unfortunately, there's not a lot I can do about that. There's an example called I2C Scanner. So yes, you go into examples, wire, and then it's in there. That's this little program. Now what this is doing, this is running. Now it was saying no devices were found. It's now saying it's found a device at 027. So that should mean this should work. So we'll try this. You did it with no backlight, and we'll see if it runs. Basically the problem there was, yeah, it was broadcast. Hey, look at that, it's gone. It's turned off. And you should be able to see where it says please subscribe. Yes, so that works. I'm pleased that works. It took me a little while there, but as always, yes, wire's wrong. You won't do any harm if you get the wires wrong, but as you've just seen, it won't work. So there we are with that one. So that there is a very basic, this is how to put a message on there. What if you want to move it somewhere else? Well, let's just have a little look. You can go into here and you go lcd.setCursor. And you start off with the column. So I'm going to go with column 4. And I'm going to say I want that 2. Bear in mind, these start at 0. So the first row is row 0, row 1, row 2, and row 3. So this please subscribe should move down, and it should move in a little bit. So let's try that. Now it's flashing away quite nicely as it loads. Yeah, it's moved. Now because of this, there's just a little thing you can do here, which is quite useful. I'm just going to go in. I'm just going to put an X there, and we'll do it. You can write to individual characters. You can write text strings, or you can write individual characters. So this means you don't have to rewrite the entire display every time you want to display something. Let's have a little look at what we can actually do with this thing. Okay, right. I've made a few slight changes to the board. Firstly, we're now using the power strip, top and bottom. These wires are just bridging the power strips. Over here, I've got 6 wires connected from D4 through to D9, which I'm going to use to say these are my inputs. I want the screen to show me the outputs. And then we're going to do a little bit of processing with them. So the first thing I need to do is come up here, and I'm going to go with uint 80. I'm doing this a little bit differently. Normally I would do this as defines. However, I don't want to here. I can't call that in because it'll probably confuse things. So I'm going to do this, and this is saying this is an array. And I'm going to go 4, 5, 6, 7, 8. I probably don't need, because they're in sequential, I probably don't need to do that. What that's doing is saying I want 6 8-bit integers. 8-bit is 0 to 255. The pins don't go that high, so that's fine. I want the first one to be number 4, then number 5, number 6, number 7, yada yada yada. Right. So they are my input pins. And what we're going to do in this code here, we are going to put a little loop in here. Uint 8DC, which is my CNTR, my counter, is going to equal 0. While the counter is less than 6, and then we are going to increment the counter. Now this is going to say whatever is in this bracket here, do it 6 times. And I'm going to do this. I'm going to go pin mode I CNTR. And I'm going to go input pull up. So what this is going to do, it's basically a little bit of shorthand. Instead of going through and saying I want to do input pull up on each of these 6 pins, I can define what they are up here, and now I can say for each one, so the first time this runs, counter is going to be 0. So let's say I element 0, which is 4, so that becomes pin mode 4 input pull up. Then pin mode 5, pin mode 6. If you've got a lot of these things to do, it works quite nicely. So that's set all of those up. I'm going to do is come down here into this little loop. And I want another little array like this. I think what I'm going to call this one V. Because this is where I'm going to put my values. And I'm just going to say that. And that's shorthand for I want all elements to be 0. Because that's where we're going to start. So down here we're going to do something very similar. In fact, so similar, I'm actually going to copy it from there. And instead of this, we are now going to go V CNTR equals digital read I CNTR. So that's going to say read pin 4, put its value in the first bit of that. Read pin 5, put its value in the first bit of that. How do we know that's worked? If only we had a little display. Ah, we do. So let's put the values on there. So what we're now going to do, we've stored all of this. So we're now going to write them out. And I'm going to do this as we've done previously. I could put it in here. I'm going to do it as a separate section. The reason I'm going to do it as a separate section is because I want to put a little bit in between here. So what we start with is lcd.setCursor. If I spell it correctly. And I'm going to put this on... we're going to start at the beginning, but I'm going to put it on the second row down. So that's where we're going to start. And what I'm now going to do is I'm going to come in here and I'm going to say lcd.print, and I want to print a single character. So what I need to do is tell it it's a character, and then we're going to go with V. Now the reason what this car thing at the front do, in fact I put a bit of space there, makes it simpler. This is something that C has called, it's called casting. A little bit like a wizard, it's going to go away and say, well, this value V, this is an 8-bit integer. And it'll print it as a number. Don't want to print it as a number. It's storing a 0 or a 1. Now I want to tell it that's a character. No, I don't, because character 1 doesn't print and neither does character 0. Ignore everything I've just said. So we're going to do that. And the thing is, after this is printed, it will move the cursor on a little bit. But I want to put a little bit of space in here. So I'm going to go print, and I'm going to tell it to print a space. And it's going to do that, and we're going to come down to the bottom, and I'm going to go like that, because otherwise this thing's just going to blur. And what this should do, I say should because I've not tested this. What this should do is every second read the value of those inputs and put them on there. They should all be 1s. So let's have a look. And of course it's found a spelling mistake, uint 8d, because yeah. And he's found another spelling mistake. I do apologise for that one. CNTR. Try again. And oh yes, of course, because I've this is the drawback of using copy and paste. Right, try again. That. Right. Not sure what happened there, but we'll try again. Primary expression before such and such a token. Computers do exactly what you tell them. This is often exactly what you don't want them to do. But there we go. Right. Oh, look at that. Look at the display. It's showing all 1s, which is what we want. Now I'm going to move one of those. I'm going to change it to a 0. It's changed to a 0. Put it back to a 1. In fact, don't connect it to anything and it becomes a 1. These are, in theory, push buttons. In practice, I'll just move that one over there. Is that going to change? Yeah, it would do if I put it into the right hole. There we go. That one's become a naught. That one's become a naught. So what this is now doing, very, very simply, is this is reading 6 inputs and it's storing them and then it's writing it out to the display at the end. Very, very simple. Now, as I said earlier, I've got a plan for this thing. If I just move some of the wires, I might see it a little bit better. Yeah, I apologise for this black wire, it's not going to get out of the way. I'm just glad this camera's, in some ways I'm glad this camera's got a manual focus because it's avoiding it focusing on the wires constantly. This is for Leopard Street. The plan is this will be part of my reversing loop hardware. Now if you've watched any of that, and if you were looking at the sensors video last time, you'll have seen the infrared sensor. And it normally, when it can see a light, I'm trying to which way around. Yeah, it'll output a 1 when it can see a light, and I think it outputs a 0 when it can't. I can't remember which way around it is. But I'm going to have 6 of them. Yeah, I've got 6 of these here. I want this to do something with those. So what I'm going to do is I'm going to come back over here. And in this bit, we're going to do something. And I'm going to come up here, int 8d, I'm not sure I've spelt it correctly this time, 3. And they're all going to be 0 as well. Now these are my 3 outputs. So if you think these V here, these are, I'll just, let's label this up here. Sensor values. That there is sensor pins. And this here is output values. I don't have keyboard correct. I don't have the output relays connected. In fact, the boards to do that aren't even built yet. I don't have LEDs and suitable resistors on this, but I do have a screen. So I'm going to come in here, and then every time we do this loop, we're going to do a little bit of logic. Now, what I want, and I will just do this here very simply. This is what I want, and this is, now for those who've never seen it before, this is what we call a truth table, because it speaks the truth and it looks nothing like a table. Yeah, anyway, data table. And the logic I want here is the sensors, as I think they work, read a 1 if there is no train. So in here, where neither of them are reading there's a train, what I want is a 0. Because this is going to drive a relay. When there's no train, I don't want the relay driven. And if both sensors see a train, I do want the relay driven. In fact, if either sensor shows that, that's what I want. Now, that is a fairly standard function, and what that is called a NAND gate. It's the exact opposite of an AND gate, which would only be 1 down here and the rest would be 0, so it's not AND. Okay, so that seems reasonable. So I'm now going to do a little bit of logic here, and I'm going to do this manually because it's fairly straightforward. So that is going to be equal to, put that in brackets, it is going to be equal to the, I'm trying to remember how to do the logical AND function is going to be V0 and V1, except it's going to be the exact opposite. And before I go anywhere, I'm now going to add a little bit of line down here because I'm going to check that 1 out first. So I'm going to do this one manually because I might as well. Else, this is showing the other way of doing this thing. Set cursor, and this is going to go. Let's have a think here. I'm going to go 0, 3. Let's put this on the bottom row as the outputs. And what I'm going to do is I'm going to put the output in the middle of all of these. So actually the easy thing to do there is set that to be a 1. So I'm now going to go LCD dot print, and what I'm going to put there is 0, 0. There we go. Upload that and see if it does what I want it to. Yeah, it might do, it might not. So have a little look. So at the moment, right, these first two, I'll just angle that, you'll be able to see it a little bit better, are showing 0, 0. So if we go by a little truth table, the output should be 1, and the output is 1. So I'm going to set, well, what happens if that one goes back to be a 1? Nope, still got a train. What happens if that one goes back to be a 1? Hey, we don't have a train anymore. So we're clear, so we've changed it back. If that sensor sees 1, hey, we've got a train. And then it goes back. I'm only going to do that for that first one. Basically doing it for the rest, there's very little point. It works in exactly the same way. I'm just trying to get this to kill some of the reflections off these screens. These screens are... yeah, this one doesn't have the reflective film over the front still. And like I say, if I turn the backlight on, it's glaring and you can't see it. There is a trick you can do with that, but it's quite hard to do, ironically, with these displays. If I disconnected that pin off the back and I plugged a different wire in, you can fade the backlight on one of these. Let's just have a little look at doing that. I've not done this before. I know you can do it, but I've not done it. So I'm going to take that off. I'm going to take this brown wire and I'm going to see exactly which wire it is. I just need to bring this in so I can see exactly which connector I need to go with. Yeah. It's actually, I can't see a damn thing on it because that's better, because of the glare of that LED. So I think I need to do it on this side. So if I do that and plug that in. Right, the backlight is not on. What happens if I put that into positive? We don't get a backlight. So what happens if I put that side into positive? We don't get a backlight. Negative? Nope, didn't like that. That was a short circuit. Right, it's definitely the right way round. That into there. And yeah, not working. Okay, fair enough. In theory, you can. I've just to work out the exact pin combination on that. Now the main backlight isn't working either. Oh, because the backlight's been told to be off. That'll be why. Yeah. Anyway, forget the fact I've just nearly shorted the thing out. Incidentally, ignore this little white chip here. That's for something else in another video. But that sort of shows you how you can use one of these things to show you the output state of something. When I put it downstairs, I'll have the backlight on so I can see it. But here we'll have a naught, there'll be another character over here, and there'll be another character over here, and it'll just show me the logic. This logic code isn't, strictly speaking, what I'm going to be using. I want it to respond much quicker than this, and then we'll use a little flag to say, do I need to update something, yes or no? And that's what we'll do with that one. So here we are. This works. You could do other things to this, like you could put a header above it. So you know, I could actually label those and do some other things. I mean, for example, if I yeah, quite easy. Let's come over here and we go LCD dot set cursor 0, so we go back up to the top. Don't need the second comma on it. There we go, LCD dot print, and here I'm going to go. I'll do a character string. I'm going to go 1, 2, 3, 4, 5, 6, like that. And we'll upload that. Hopefully that should work. Ding. And what that's done now, it now labels. Get this blasted black wire out of the way, you might be able to see it. It's now labelled those inputs. So yeah, that works. And then if I just change that one, it's now clear which input has changed. So you can see the logic going down to the bottom, and you could put an extra set of labels in on the bottom, which I probably will do. And this sort of method of using an array works quite nicely. Now, there's another little way of doing it, because here we're taking the values and we're going in. What you could actually do, and I'm not going to do it here because it's not worth doing it here, is you create another little array that would sit up at the top, and it would look, I mean, if I want to sort of drop this thing in here, uint8 ts, and this is going to be a two-dimensional array. It is going to be 4 by 21, and then it is going to equal 0, all 0. That's a two-dimensional array. So basically what that's saying is I want 4 arrays, each of 21 characters. 4 lines with 20 characters. The 21 is for a null terminating 0 at the end. Just so you can do that. But you could go in and you can say, I want to write character at position 4 stroke such and such. And then when I output, I want to output all of that. Here, that's not a good idea, because these displays aren't particularly fast. So at the moment I'm writing out single characters, which is quite quick. Writing out them all, it doesn't take long, but it takes a little bit longer. If I was using, I can get hold of one without dropping it on something. If I was using one of these, as is how Leopard Street works, I have an 8-row 22, I think it is, character display. And I go in and I say set character such and such to be this, because there's titles, there's all sorts of things on there. But what it means is I can have lots of code that changes things, and I have a little bit at the bottom, and you've seen how we've used flags before. I have a little flag value that says something's changed, and you get to the bottom and says, well, actually we're only going to output if something's changed, and then it just drops that whole array onto the screen, which it works. Here, because I can turn the backlight on and off, I could make it flash in the code. I'm going to investigate how to wire that up to do the fading. It's really simple to do if you get the wiring right. You just use a command called analog write, and on an Arduino there's certain pins you have to use on the outputs for it. And you could say I want the backlight at 50% brightness, or 25%, or 75%. I will investigate that, and I will do that in another one. Anyway, to conclude, because this has gone on far enough, we've had a quick overview of the different types of screens. So, the TFTs, the LCDs. A quick look at what sort of screen you should be using and what's appropriate and what isn't. In this case, this is perfectly adequate for one of these. In fact, actually, a 1602 I would have used it, but it hasn't got that board on the back, and I didn't fancy finding one and trying to solder it. So there we go. Yes, we've looked at the Arduino Nano. Actually, it's quite a good little board. They are fairly cheap. If you only need low power, I mean, like I say, this is reading 6 inputs and it's driving 3 relays. I am not overtaxing the thing. I did think, Ian, if you're watching, I was thinking about using 555 timers, which is sort of what this thing over here is, having a little bit of a play and then using some logic chips. And in the end, I realised I just use an Arduino. I've got them, and it's cheaper because I've got them. Yes. So we've learned how to do that. We've seen how to connect one of these screens. We've seen how to find the address of one of these screens and then how to connect it properly. Seriously, it wouldn't be one of my videos without something like that going wrong. It's amazing how often I get those 2 pins the wrong way around. You can chase them as many times as you like, and by the time you've turned something over and turned it back, you've forgotten which is which and they're going the wrong way. If you're using these jumpers, it doesn't matter too much. We've seen the library, and we've seen how to write simple messages. The library does a little bit more. You can have custom characters. There is the data sheet for the controller chip. It's I think it's a Hitachi chip that's on the back of one of these things. It's got a character set, so you've got the basic characters you might expect, and then there's some other characters in it as well. I think there's a smiley face, and there's a few other bits and pieces. You've got, I think it's 4 characters you can define yourself. So you can sort of do a solid block and try and do like a bar graph if you want to. If you're going to do that, use a different screen. It's just easier. These things are simple. Now, when the reversing loop controller is being built, that'll be on the main channel. But hopefully it's a little bit clearer now how you can use a screen with a microcontroller to view status. Or, which I'm doing here. You can also use it to display simple debug information. You could, there's quite a bit of space on here. Yeah, if you've got a lot of things that are just single characters on off. Points, for example. You can have a row of, say, 10 points with a 0 or a 1, so you can see which state the points are in. Or do the same sort of thing with signals or block occupancy sidings. It's excuse me. It's a nice little window into what the microcontroller is doing, either to give you some information that you might need or to give you some sort of debugging information. Future videos will use the screens as well as the serial monitor to look at what we're actually doing on here with the other little screen. I hope you found this sort of thing a little bit useful. If you're going to use an Arduino for anything and you're going to give it some inputs, these are useful. Leopard Street, for example, my board controllers have got, as I mentioned, the little screens. The reason they're there is so if I tell a point to change and nothing happens, I can go down and I can look at the screen. And the screen will tell me what the controller thinks the point is doing. So if the controller says, well, the point's changed, and it hasn't, I know there's a problem with the hardware. If the controller said, you've not told me to change it, I know it's a network issue sort of thing. So it helps with debugging. Anyway, we shall return to bits of this nonsense in future episodes. In the meantime, I will leave you for the rest of your day. Thank you very much. If you liked this, an uptick would be useful. Comments, shares, subscriptions, all the usual YouTube gubbins. There's plenty of other information on this sort of thing online. I'm going to carry on with these in a little bit. This is just a very simple. We're not doing anything fancy, because I'll probably blow it up if I try to do anything fancy. But this is the sort of thing you can do. Anyway, enjoy the rest of your week. I will catch you all in the next video. Thank you very much, and goodbye.